It's about Gearings Point, the Astronomy Education display. This image is of Gearings Point in early 2019, when we submitted the initial application to the ward committee. First question is, what is Gearings Point? Many of the locals know what it is, but for the non-locals, it's a permanent display of 36 astronomy education tablets covering 21 different topics, which give an introductory but a comprehensive overview of astronomy. The intention was that you can stand and read an A4 page in front of you. So we had to magnify the normal 210 by 297 2.7 times and ended up with 560 by 795. It was mounted at 60 degrees, so that if you stand in front of it, it was raised about 100 millimeter above the paving. There was a restriction that the mounting slabs could not extend above the whale watching ring wall. Where is it? This is from the site plan. There's the old harbour in Hermanus. Here is Marine Drive. This is the Gearings Point parking terrain. And this is the whale watching ring, which receives the most tourist feet of any place in Hermanus. A closer up of the approved site plan indicating where the educational tablets are going to be and all the topics that are covered in it. It refers to an analytic sundial. And also there are 5 more tablets which will be installed by SANZA next year. A vertical overview, a bird's eye view. There's the trig beacon plinth on the north side of it. Here is north and there is south at the top. There's an analytic sundial. It's 3 meters in diameter and about 1.5 meters high. Then on the north side of the vertical of the plinth, we've got a vertical sundial, an east vertical sundial, west vertical sundial. And on the south side of the plinth, there's very informative tablets on the role of trig beacons in the survey of South Africa, which Johan Retief wrote. And about 500 millimeters further south, there's a tablet showing the cardinal directions of sunrises and sunsets. If we look towards the east, the summer solstice sunrise is over here. If you stand there, you'll see, look through a V slot in the wall. The equinoxes sunrise and the winter solstice sunrise, and the same for the sunsets. This is in words what I've just indicated to you in the diagram now. And the bottom one is an explanation of the history and role of trig beacons in the surveying and mapping of South Africa against the South Wall. This is an image of the analytic sundial. It's quite big. It's chemically etched onto stainless steel. You can't miss it, and it attracts a lot of attention from visitors trying to fathom out how it works. This how to use sort of gets read as an afterthought, and then people start finding out how to actually use it, but it works very, very well. There's the cardinal directions plinth showing the directions. A north vertical sundial, of which there will be a photo later. East vertical, I've never made one before. It actually works quite well. There will be a photo of that proving it. The west vertical sundial. There's 2 little sun on the south side. And then there are 2 very interesting information tablets. This is the equation of time showing the components, its components. First of all, there's the tilt of the rotation axis, which obviously gives you a 6-monthly cycle. And then there's the elliptical orbit of the Earth, which is going to give you an annual cycle, sinus curve, and you add these 2 together, and then you get the solid line. That's the equation of time in a curve. What I actually prefer, and I found more informative, is the analytic form, which also gives you the declination of the sun and the correction. If we look at the date now, we're at about the 1st of December. So the correction to the equation of time is minus 11, subtract 11 minutes from the time you read. What's interesting about this, it shows you the typical squashed figure 8 and a lemma. You will get this shape if you mount a camera on a tripod and you take a photo of the sun every day at 12, or if you mark the tip of a shadow stick once a week at 12, doesn't matter what day of the week it is, and it's going to show you this analematic shape. It's also interesting, you can see that according to Kepler's laws, in our summer, the sun is closer to the Earth, or the Earth is closer to the sun, so it rotates faster when it's closer, according to Kepler's laws. So the difference between the apparent sun time, or local solar time, and the South African standard time changes more rapidly. You can see the fat diagram at the bottom. And then in winter, when we're further away, the Earth is moving slower, and you can see it changes less. You can also look at the dates of the equinoxes, and the southern hemisphere summer is 3 days shorter than its winter, which is all illustrated in this analemma. The Trig beacons, history and role, two very informative information tablets, which Johan Retief composed. It's interesting to show that the astronomical origin of Trig beacons in South Africa. In 1754, De La Caille measured the arc of the meridian from Cape Town to about Aurora, a distance of 137 kilometers. And he found that the Earth was pear-shaped, with narrower in the southern hemisphere. But his result wasn't widely believed. So the exercise was repeated 100 years later by Maclear. These are interesting historical photos of the instrumentation used to do a repeat of this measurement of the meridian over a distance of almost 500 kilometers. And the difference between the two is that Maclear incorporated the gravitational attraction of the nearby Table Mountain on the lead bob, which is used to determine. Okay, the educational themes on the left side are theoretical in the sense that it's an outward journey from Earth, the Moon, the Sun, the solar system, galaxies and clusters of galaxies, to the Big Bang. Information, a very nice diagram of the cosmic pie, which Jenny composed. Origin of the elements, which was only completed in 2017, when the first fusion of neutron stars were detected. Stellar evolution, and there's also some historical information about pioneering female astronomers and ancient astronomy. The west side are more practical, observation aids and how to use them. The eye is the most versatile. Binoculars second most important, then telescopes, space telescopes. What celestial objects there are in the southern sky, and a lot of the northern hemisphere visitors took photos of these maps there. Observing tips, celestial sphere to understand sky maps. Sorry, let's go back one. And then there's also astrophotography and space exploration and the search for extraterrestrial information. So it's quite a wide range. It's an introductory but fairly comprehensive overview of astronomy. We've said enough about the display tablets dimensions. The black and white printing is achieved through chemical etching on stainless steel, and the color diagrams or photos are reverse printed onto 5mm perspex sheets, mounted 7 meters above it as a protective or a color printed covering. I think, Derek, if at this stage, well, it's still quite bright and way far from 25 past. Let me continue with the slideshow, and then we can go to Mick and Indy for a live view of the GPAED. This was the first sample tablet which we received. Gives you an indication of the black and white, the size of the tablets. First of all, it's obviously Dion, and that's the chemical etching, and this gives an indication of color, which looks beautiful. Mounting it was quite a problem, and a lot of thought went into this. And I must thank Dion and Derek as the part of the committee in coming up with designs. The mounting slabs 800 millimeter high so that it didn't protrude above the wall, 565 to ensure the correct aspect ratio of an A4 portrait page, and mount it as high as possible so that you can read it easily. These are the mounting slabs cost while they're drying. And then to fix the stainless steel to holes that you drill into the concrete is quite a problem because it's very valuable and we would like the stainless steel to remain there, not be recycled. So what ABE Construction Chemicals eventually agreed to is using coach screws because they've got a large flange, and drill a hole into the concrete, blow out all the dust, and then use Epidermix 396 as the best available epoxy at the moment, and that's what we used. So a lot of thought went into this, and then an M5 button head was used to screw the Perspex covers or color printing on top of it. So this is actually quite a lot of thought went behind this. The project timeline is actually quite interesting. I think even the local members will find it interesting. In 2008, Steve Klein donated his own 13.1-inch telescope to the club, and then we wanted to build an observatory to house it. So a proposal was submitted for an Astronomy Education Centre and observatory to council, and it was approved on the 1st of September 2009. That's 13 years ago. But then it was approved and we had insufficient funds. March, we applied also for funding from the NLC, which we received in March 2014. By which time we had money, but then we needed a different type of approval. The original rezoning had to change to consent use because 6 local authorities had amalgamated into the Overstrand municipality. So this was incorporated into the Fernkloof management plan and eventually not approved in 2019. We only heard about it on the 27th of November 2019 formally. We'd heard about the non-approval a year earlier. So in March 2019, we submitted a revised Gearings point astronomy education display, just taking the educational material from the initial proposal and mounting it at Gearings Point. It was approved by the Ward Committee and the Overstrand municipality in March 2019. December, then, well, we only received it officially in January, and then COVID hit. And it took us until the end of December 2021 before we could submit a quotation or cost estimate-based proposal to the NLC. And we eventually received approval on the 7th of April 2022 this year. But there was a distinct rider to that, sting in the tail. The project, because it was so old, had to be completed by the end of the year, and whatever money was not spent by then would have to be paid back to the NLC. So that was a crash course, and it was indeed very, 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 very busy and very challenging to the committee. In July 2022, the site plan was drafted and approved by the OSM and also the Local Heritage Committee, I might add quite enthusiastically. And the installation was completed in November. And in December, before the end of the year, we will complete the final orders and payments. The project sequence is quite important. The first step, and that was probably the most important step, was the science editing of the draft tablets. The initial tablet drafts were composed by or compiled by the members of the Embanus Astronomy Committee. And they were randomly allocated. But they were written by amateur astronomers, in probably not a reader-friendly or reader-attractive format. So we had to find a science editor, one person that could edit all of them, cast it in the same draft, and also use simple terminology, which will make it easy to read and attractive to read. And we were very fortunate in finding probably one of the best in the country, in Professor Mike Bruton. He did a fantastic job. He did it in 6 weeks, and I think that was an important hurdle to cross. If we were not convinced that the final product, Mike's final product, was good enough to, in our opinion, attract attention and serve its purpose, we would have canned the project. So, Mike, your contribution to the success of the project was of inestimable value, and I think probably the most important of everyone. So, thank you very much for that. Then it went to a local graphic designer, Jenny Corey, and she did a fantastic job of the graphic design of Mike's final drafts. These had to happen in sequence, as you can see there. Mike completed his science editing on the 12th of July. Remember, approval on the 7th of April. Graphic design completed by the end of July. Then parallel processes, the chemical etching of the black and white on stainless steel and reverse printing on perspex by Dowd engravers, casting of the foundations and casting and installing of the pre-cast mounting slabs, 300 kilogram plus. They happened in parallel and they were completed. That the design of the final chemical etching tablets took a lot of time, a lot of to and fro between us and Dowd engravers, and it was only approved finally, I think, on the 7th or the 9th of September. But the final tablets were delivered, I think, in around about the 10th of November. Then the installation of the educational tablets and installation of the beacon area enhancements during October and November. So this was a very tight schedule. And I think if we had more time, we could have done some things slightly differently. Now I'm relying on a picture being worth more than 1,000 words. So I'm going to show quite a few pictures of the process, which I think the technically minded will find interesting. The engraving starts off with a laser cutter at Dowd engravers. It's quite big, as you can see. There's the, let's call it the cutting edge of the laser engraver. Here it's cutting very small things, holes and small little, looks like visitor cards. There are our educational tablets, 800 millimeters high, and there's the one of the stellar evolution. Now, all stainless steel is quite dirty, fingerprints and all the rest of it, oil, so it's got to be very, very rinsed, very cleanly through acid bath, alkaline bath, and I think a neutral bath, neutral pH. There's a lot of chemicals involved in the process, so there's a lot of rinsing. And that had quite a huge impact on the whole process, because the baths, when you had load shedding, the baths had to come up to temperature before you could restart production. This is as far as we were concerned, I thought is the heart of the process. And that's the chemical etcher. You can see it is simultaneously chemically etching 4 of our information tablets, gives you an indication of the size. Then once it's been etched, the stainless steel, probably about 1.2, 1.3 millimeters deep, you get the ink injected into it, and lots of masking and rinsing. And all the masking and rinsing is done manually. So you join the queue, the production queue, and you cannot speed it up. You cannot cut out any steps in it. So we had big fights with the production manager at Dowd engravers to try and get delivery earlier. But he stuck to his guns and he said, you can't make it earlier. And he did deliver according to promise. But you can clearly see some of our tablets there. The final step before it goes for baking is to get rid of the excess ink. And this was done manually. You can actually see this is the end of a video clip, and there it's partially cleaned. So that's how the tablets were actually manufactured. Then installation at Gearings Point. Quite a number of interesting pictures. First of all, the foundations had to be cast. And because the paving was inclined at a maximum 4.5 degrees, we could put at most 4 tablets next to each other. There's one case where there are 5 over there. So there you can see the steps down in the foundation. Installing the mounting slabs with a forklift, big rubber wheels, so the point load was not too big for the paving of a conventional forklift. They're installed. There are still a couple outstanding. And then the actual installation of the tablets. The first step is to mark the holes where they've got to be drilled. And here you can see Dion and one of Ocker Builder's assistants marking it with pencil against the mounting slabs. And then the back-breaking job of drilling perpendicular to the slabs. Then you have to, it's obviously drilled at 30 degrees because of the 60-degree mounting angle. So you've got to get rid of all the dust in there before you epoxy it. And one of the indispensable tools proved to be a 4-inch nail, which someone had knocked into the paving. We pulled it out, and its head worked very well, scratching out 95% of the dust from these holes. And then the final 3 to 5% was sucked out with a cordless industrial vacuum cleaner, which worked very well. Hold it over the wall and you suck it clean. Then you've got to etch it. And we had to mix the Epidermics 396. And this guy with a stick in his mouth did the first mixing, and then he became the expert, and he did all of it afterwards. Then once it's mixed and it dried quite quickly, we discovered on the first day, within half an hour, we couldn't use the second batch. Dion is injecting it here with a 50mm syringe. And then you've got to seal the tablets with their coach screws mounted through and the perspex behind it. There you can see it's completely sealed. Then it's installed into place, and the final step is to screw in the M5 by 17mm button head screws to fix the perspex cover or color printing screen on top of it. So this gives you an idea of the process. This was the very first tablet that was installed. Don't ask me why. I don't think there was a logical reason for it. In any case, that was the first one which was installed. And I kid you not, within 2 minutes, there was a tourist from Haiti who stepped to the front of it and he read the whole tablet. And of course, he asked lots of questions before he had to leave to catch a flight back home. Just looking at some of the tablets, I'm just taking a selection. We've still got to finally decide how to make it available on the website. Locals must not be easy enough to read it on the website and not go to the site, look for it yourself. So this is the graphic design for one of the tablets, the Earth, which is important for schools because, amongst others, it addresses seasons very, very well. And they learn quite a lot more about the evolution of life on Earth and its composition. Magnetosphere is not covered in the curriculum, but that's quite an important part of it. This is what it looks like if you take a photograph of it installed. The holes that we had drilled were slightly too small, so if the coach screw is not mounted exactly perpendicularly, when you put in the button head screw, it induces stresses in the perspex which cracks, but as long as you can read it, it's fine, as long as you can't remove it. The sun, it's the very colorful one, you can't actually miss it. It's not part of the curriculum explicitly, but there's a lot of interesting information on it as well. And this is what that looks like in real life. You can see how colorful it is. It's impossible to ignore it. And back to schools of importance is the solar system. And there's some more interesting information about how it was formed. That's not covered in the curriculum, but all the planets are very definitely, the asteroids are referred to. Now, all of us know that the asteroid belt is, I think, between Mars and Jupiter. But if you look at the colored diagram of the different types of asteroids, I would estimate that at least 95% of people will learn something from it, even experienced astronomers. And then, of course, spectacular images of comets. This is what it looks like in the real life, and this is a very attractive tablet. It's quite a complex, but the simplest way of explaining stellar evolution makes the statement that the life cycle of every star is determined entirely, totally by its formation mass, all formed from the collapse of giant cold hydrogen clouds, molecular clouds, more or less like the solar system formed. And then what happens to it is determined entirely by its mass. If it's less than 0.1 of the sun's mass, it's not sufficient to achieve high enough density and temperature to trigger the fusion of hydrogen into helium. So it just carries on as a brown dwarf. About half a solar mass, you've got a red dwarf like Proxima Centauri. It can trigger hydrogen fusion, but nothing more. So it continues as a red dwarf for trillions of years, outlasting the life of the galaxy to date, in theory. From a solar system start up to 1.4, the Chandrasekhar limit, it will live for about, on the main sequence, for about 10 billion years, then swell out to a red giant for about 1 billion years, and then it'll cast off its outer layer as a planetary nebula, which exists only for about 10,000 years, and the remnant core is a white dwarf. More massive stars end up as supergiants. This is only hundreds of thousands to 10 million years in lifetime. And then depending on the size of the star, the remnant core after the supernova explosion is smaller than 8 solar masses. It ends its life as a neutron star, which if it's magnetic becomes a pulsar. If it's heavier than 10 solar masses, gravity prevails and it collapses as a black hole. This is actually, that's the diagram. This is what it looks like inside. You can almost read it clearer on the tablet itself. Then quite an interesting and a very popular one is the eye. How it works, how light is perceived, a lot of interesting information. It was drafted by Peter Harvey initially. And then more about dark adaptation, which is of course important for observation with the eyes, binocular vision, which is wide for the eyes, and then a very useful stereoscopic vision. It's an image of the asteroid Ryugu, taken by Dr. Brian May, the lead guitarist of the rock band Queen. And you can actually see the stereoscopic image. Our estimate is about 60% of the people can, and the other remaining 40% can't. So this is quite interesting. And then this is what it looks like. Okay, it's not good. There was too much sun. You can actually see the reflection of the photographer, but it works very well. This one is specifically included, the telescope designs, because all these diagrams comes directly from the Sky Guide at Africa South, the Sky Guide as we know it. And that's why I included this. But this is also quite an interesting one, and this is what it looks like in the real life. Then for Northern Hemisphere observers, this was quite interesting, and quite a number of photos were taken of these sky maps of the summer and winter constellations, and of the spectacular images in the southern sky. This is what it looks like in the real life. Very useful basic tips for observing. And then sky maps, and I also observed quite a number of them taking photographs of these sky maps. Obviously Northern Hemisphere observers, but I think our Southern Hemisphere observers can learn something from it as well. This is what it looks like in real life, quite attractive. And then installation of the horizontal tablets. It's mounted flush with the paving. So we used N12 by 70 coach screws, welded onto the backside of the tablets, 3 millimeter. Here's the cardinal directions, being the coach screws positions are marked, and then before the holes are drilled, then epoxied in place. And the same is done for the analytic sundial. Now, these are the cardinal directions. It's not very clear, you can't read it from here, but that is the cardinal directions tablet. And there you can see the summer solstice sunrise slot in the wall, the equinox sunrise slot in the wall. If you stand here on the spot, you will actually see it rising through there, and the winter solstice sunrise slot. And it's obviously similar for sunsets. This shows when you've mounted tablets, we started from one to the end. You hold it in place with lintels so that the epoxy can set. There is the analematic sundial installed, 3.2 meters over there, and there we're nearing the end. You can see we're nearing the end. Now, a crucial piece of technology which we got from Dowd Engravers to clean before we finally fix the tablets was to use Plus Supreme multi-surface cleaner. And Derek brought his Boermarker plan practicality to this. He sprayed half of it and then wiped it over, and then this stuff is really magic. It wipes it absolutely clean, both the stainless steel and the perspex. So there, Derek is busy cleaning a tablet, and Dion is screwing in the M12 button heads, and he's also Loctiting all the bolts so that they can't be screwed out and removed for recycling. The plinth got similar treatment. There they've all been installed, and we used lintels to keep it in place for the epoxy to dry overnight. This is the west side with the west vertical sundial, north vertical sundial, and this is the east vertical sundial and the analemma. That is the equation of time components. And on the south side, you can see the information before the protective covering was pulled off, the plastic covering, the description of the role of trig beacons in the mapping of South Africa. This shows two useful pieces of technology. The seat is a very effective antidote against overexerting a back from excessive bending. Some of the locals might recognize it as a very useful seat for getting your eye behind the eyepiece of a Dobsonian telescope. And then when you've got to kneel on the hard paving, this softens it quite a lot. Final inspection of the analematic sundial, and you get an idea of the complete installation. Very nice photo. I suspect it would be Dion Derek, because he's not on the photo. There's Mick, the analematic sundial, and quite a nice image. You can see they've now been cleaned and polished, and everything is neat and tidy. That brings us to the installers, Dion and Derek and yours truly. And I might add that I want to say thank you on behalf of the HAC and the users in future. It was a totally unreasonable demand on their energy and on their time. I think we spent about 8 full days at Gearings Point doing the installation. The problem with the process is once you've started it, you can't stop it. So when we started it, we had to continue right through. So it was totally unreasonable demand of the project. I must thank the installers for their hard work and energy. And then Mick took us his final panoramic view of it. I think I'm going to complete the final comments before we go to Mick. He can show us the live image of that. Some observations regarding the project as a whole. There were surprisingly many foreign visitors still at Gearings Point late in November. And our impression was that the Germans were dominant, 50% at least. The important conclusion is that the display does unavoidably attract a lot of attention, and it elicits lots of questions and many compliments. I must mention a few of them. There was one chap, he was obviously well informed, a British chap. He referred to the biggest analematic sundial in the world in India. I think it's something like 22 meters. And he spent about an hour and a half there. And when he left, he gave an informed opinion, he said this is really a world-class exhibition and he wants to congratulate everyone involved. There was a German who had to catch an aircraft, and he used words that I won't forget easily. He said it creates a very attractive scientific atmosphere, and it elicits the feeling in you that you want to come back and read some more. And he wanted to know where he could read more about it on the website. So the final conclusion is that from a visitor, a casual visitor, or even organized tourist, the display serves its purpose to attract attention. And when you've started reading one screen, you're hooked. And then you can decide how much you want to learn at one time. So now that we're convinced that it serves its purpose in situ, the focus must move to its effective utilization. It is a fantastic educational facility, and it must be effectively used by the schools. And we will do that in conjunction with community organizations and the circuit manager of the Overstrand schools. And I just want to, there are a number of thank yous that I've got to make before we go to Mick in about 2 minutes' time. First of all, we have to thank the NLC. We couldn't have done it if we didn't get the money from them. We have to thank the Overstrand municipality, all its organs, for the written approvals for doing the project. I have to thank, or the committee has to thank, that's Dion, Derek, and myself, the Hermanus Astronomy Center Committee for drafting the initial tablets. A bunch of amateurs who did excellent work. I think Mike can confirm that. And the committee itself, Dion and Derek, I think you might remember, if you think back to my chairman's report at the end of the year, I said the project cannot be completed and will not be completed if Dion was not willing to continue with it. And it's true. It could not and it would not have happened without Dion's eye to detail. Dion, thank you very, very much. And Derek, you came into the project more or less cold. It was almost unreasonable, but you picked up very, very quickly and your contributions were huge in the end. So thank you to the two of you. Then I did refer to that earlier of the subcontractors. The biggest appreciation must go to Mike Bruton. It's absolutely astounding what you did, taking the very, very amateurish drafts and converting it into reader-friendly and reader-attractive. And I'm using terms used by visitors, not by myself. Mike, you did an absolutely fantastic job. I think your contribution was probably bigger than anyone else. We have to thank the graphic designer, Jenny Corey. I think she went far more than the conventional extra mile. Dowd, I think, did an exceptional job. I must add that we got lots of email communication from them, but very little detail. Mike did go and inspect the first draft tablet before it was delivered, but we didn't ask him about his thoughts of the company. So at the end of September, Derek and I were very concerned. Dion had been consigned to the Kalahari for 3 weeks at that stage. So we went to Dowd Engravers and we were blown away by their technology and the effort they were taking with our project. And then finally to Akka Builders and his workers in particular. They definitely went the extra mile and they accommodated. So thank you to all the subcontractors and thank you to everyone listening here. And Derek, if you can now pass the baton to Mick and Indy at Gearings Point, that'll be fantastic so that we can see a live view.
Okay, Mick, can you hear me? Can you switch on your video and show us? So if you could just stop sharing, Pierre.
Can you see and hear us?
Must I stop sharing?
Yes, please.
Must I stop sharing, Derek?
Yes, please. Go to your Zoom menu and stop your sharing so that we can see his video maximized. That's
okay.
it. Okay, Mick, you can go for it.
Have you got my picture there?
Okay, it's a bit blurry at the moment. Yeah.
Unfortunately, we were unable to.
Oh, you're not there now.
No, we've had to move on our bicycles to 205 Main Road. So all I'm giving you is the photo that you saw that Pierre had a better picture of. But
okay.
you can see it is, yeah, it's a wonderful picture. I agree totally with everything that Pierre said. It just shows that whole background. You can see Pierre walking out of the a job well done, and we had you and all the work team there as well. So yeah, just sorry, I'm afraid the my cell phone wasn't able to pick up enough data there to be able to carry on with the show. So we've come here.
All right, thanks, Mick. All right,
Okay.
thank you very much for that, Pierre. Has anybody got questions for Pierre? Okay, Pierre, you can maybe just put your video on again so that we can see you talking. All right.
Yeah, no questions, Derek, but just to say a very big congratulations to Pierre and all of you for having built and developed such a world-class facility. I think all plaudits must go to the committee and to you guys who've driven the project to such a beautiful conclusion. Thank you.
Yeah, if I could add my congratulations, I think it's been a fantastic project, been a privilege to be involved in it, and congratulations for your determination in taking it through to completion on schedule. Very well done.
Thanks, Mike.
Pierre, of course, was the driving force behind this whole thing. He did an enormous amount of work, particularly in the design and the logistics and organizing everything in its sequence. He was just continuously at it, I think, since the beginning of the year, big time. Since the trigger was pulled by the lotteries board that it had to be done by a certain time, I think it was just non-stop for Pierre. So thanks very much, Pierre, for your dedication. And I think it's actually a good legacy for you, for Amanus. All right, great. As somebody said in the comment, a beautiful legacy and inheritance for future generations. All right, thanks, Pierre. Anybody else? Chris, go ahead.
Well, firstly, again, on top of everybody else's congratulations, I think you did a magnificent job there. On the subject of the cracks in the perspex, I suggest you try a reparation method on some scrap materials, and if successful, go to the installation. Perspex is dissolved by chloroform. So if you get a small syringe with chloroform in it, you can inject it at the site of the cracks, and the capillary action will take it through, and hopefully it will seal everything up.
Thanks for the suggestion, Chris. It was the intention to address it later. We've just not had time to think about the technical details, but your suggestion about chloroform is taken note of. And I can also just add that as part of the project, it's a once-off funding. The budget does provide for a spare set of perspex tablets, because if any damage happens, it's going to happen to the perspex. And we will, without disclosing exactly how we can remove it, we will be able to remove and replace the perspex. So while we've still got the funding, we are having a spare set printed. Hopefully we only need it in 5 years' time. But thanks for the suggestion.
Thanks for that presentation, Pierre. It was great. And I will put the recording up on the YouTube channel and forward the link to everybody. By the way, I saw John Simpson at the planning office yesterday. Seems like he's working there again, so I'll send him the link as well. He might be interested.
Yes, I think we must send it to everyone involved, all the subcontractors.
Yeah.
I actually remembered too late this afternoon to ask Peter to send a link to Sansa, but I will definitely forward the link of the recording to them because they will become part of it in the first quarter of next year. So for me personally, and I think on behalf of the committee, thank you to everyone for attending. And we are grateful. And I hope it is justified that it will be a long-term legacy of astronomy education and in a small part of the HAC. Thank you, everyone, and have a good evening.
Congratulations on a wonderful project. It's outstanding.
Thanks, Pierre.
Yeah, congratulations, Pierre. Have a good, restful Christmas.
Sorry, say where you're on.
Dankie vir Pierre, dit was 'n baie goeie voorligting en wel gedaan met wat jy bereik het.
Very well done, Pierre.
I am guilty. I did not mention your huge role as part of the original design committee. I think the original design was fleshed out between Johan and Dion and myself. And Johan's input was invaluable. He drafted quite a number of the tablets. If you look at the tablets, they're well drafted, and that Mike didn't have too much trouble into converting into readable. Johan was probably the culprit. So thank you very much for your huge contribution to the project, Johan. Apologies for not mentioning that before.
Okay, thanks. Thanks very much, Pierre. Then anybody else with comments? Okay, so we'll say thank you very much, and we'll see you next time. And then we'll log off the session. Thanks for a great presentation, Pierre. It was excellent. All right. Okay, everybody, we're going to end it now. Thanks.